Hello dear students, welcome to the TEQIP Faculty initiative of Let's Crack the GATE. Welcome to the module 2 of Power Electronics. So let's begin today's class. So till now we have studied about single phase half wave uncontrolled AC/DC rectifier with various types of loads such as R load, L load, RLE load, C load and various other RE type load and others. Now today's topic is related to inductive types of load. So today's topic is effect of freewheeling diode on inductive circuits. So basically circuits, or you can say loads basically. So we have studied that when in the single phase half wave uncontrolled rectifiers, that whenever the inductive loads are there, means either you talk about the pure inductive load, or you talk about the RL type of load, or you talk about the RLE type of load. We have observed whenever there are inductive loads in the circuit present in the power electronic circuits, the output waveform was like this. Means if you talk about the output voltage waveform, it was not just showing the positive cycle, but some portion of negative cycle also it was showing like that. So here we can, and in case this is in case of RL or RLE type of load, and in case of pure inductive load we have observed that the output voltage there was no rectification actually taking place, and output voltage was as it is like input source voltage like this. So what is happening here, that if you observe these two waveforms, what conclusion you are deriving here is that when inductive circuits are there, the inductor does not allow sudden change of current, because of which, and also inductor until unless does not discharge itself fully or de-energize itself fully, it does not allow the device to turn off, because the L di by dt across inductor becomes very high. So what is happening here, whenever in the circuit there was no alternate path available, because of which this some negative portion of output wave is also coming in the average output value like this much. This is some negative value. So what is the effect of this negative value? Let's say if we have got pure resistive load, for pure resistive load the output was like this, alright, and its value was Vm by pi for half wave. We are not averages, Vm by pi. But what is happening here, you are getting some negative value of voltage. So what is the effect of this negative value of voltage is that it is reducing our output voltage, average value. So we have calculated this thing, that for resistive load V naught average was Vm by pi, and if this point was beta, so we have calculated that for this is for R load, and when it was RLE type load or RL type load, the average value was Vm upon pi 1 minus Vm upon 2 pi 1 minus cos beta. So what is happening, whenever beta is there, because of this beta, from pi to beta, because of this extra area, this area is also known as loss area. It is also known as loss area. So this, because of this loss area, the net average output voltage was becoming lower than its value, than the resistance value. Alright. So what is happening? So now, but means this does not mean that we stop using inductive loads, and in many cases, just like in pure inductive case here, there was no actually rectification was not taking place actually. But if you go for DC motors or highly inductive loads, alright, such as electronic chokes or choke coils, there we have to use a very high value of inductor. So does that mean that we stop using the power electronics AC DC rectifier circuits? No, not at all. So, for such kind of things we use freewheeling diode in the output circuit or load circuit. So, what is the configuration of freewheeling diode? Let me make it here. If you have got and if you understand it for the half wave circuit, then you will understand for this concept for the all types of circuits, whether it is single phase half wave, full wave, or 3 phase half wave, full wave. So, this was our load, and for the time being I am taking RLE type load, I am taking it, and this is the freewheeling diode arrangement. So, freewheeling diode arrangement is made anti-parallel to the load. Alright. So, let us make the references. This is our V naught, this is I naught, RLE with these polarities. This is freewheeling diode current reference, this is freewheeling diode voltage reference, this is diode reference, this is diode current reference, and this is source current reference and voltage source voltage reference. Now, please note down one thing here. Till the time freewheeling diode was not there, so we can see that I naught, ID and IOS were all same. But now, when the freewheeling diode comes into action or in the circuit, in that case source current and load current will not be same. Alright. So, before going for the working of this freewheeling diode, I just want to make another concept here also. Just there is, whenever we have got very high inductive values of load. So, in that case, in my last lecture I have discussed about the concept of discontinuous mode current and continuous current mode current. So, I have explained this thingy there, that the discontinuous current mode is that where the load current becomes 0 for some value for some time. Means like this, if you are drawing a load current, so if your load current is like going like this, so here you can observe for this much instant the load current is 0. So, this is called discontinuous current mode. But if you observe for highly inductive loads, many times it happens that the load current remains constant like this. Like this. So, you can see that load current does not become 0. So, that is why this is called continuous load current mode or continuous current load mode. Here you can see that this is, you can see these are ripples. So, this is minimum ripple, I minimum, and this is maximum ripple, I maximum. So, the load current varies between I minimum and I maximum. Load current varies between this. Alright. And what happens, just like if you have already know about DC motors, any motor will, for a particular type of load, whatever load is applied to that motor, will try to take a constant current, a continuous current from the supply, alright, and a constant value of it. It will try to take less to less ripples from the supply, alright. So, what is happening when we talk about the continuous current mode, generally we take in, for our study purpose, we take its approximation as constant current load. Constant current load means whatever this CCM mode I have drawn here, this can be approximated to, this load current can be approximated to some constant value of capital I naught. Alright. It means that no matter what, the load current means the load is deriving constant current from the source or from the power electronic circuit. So, such kind of loads are represented by this. So, whenever you see in any question a load is represented by this, and whatever value is written there, first of all this value is average value. Second thing, this is representing a continuous current load which is drawing this much of current ripple free, alright. So, please keep this thing in mind. So, what is happening here, I am taking this RLE load, I am modeling it as, I will model in further my example as this constant current load. So, before that I am doing what is happening for a RLE type load here. So, let us start with the waveforms. Okay. All right. So, this is the source voltage. Let me correct it to make it little more accurate. All right. So, this is my source voltage with amplitude Vm, and I am going to draw load voltage, I am going to draw load current, I am going to draw source current, going to draw freewheeling diode current. I have told you that when the circuits start becoming complex, you may have to draw many waveforms. So, you cannot cram all the waveforms, just understand the concept. And I have to draw let us say diode voltage, main diode voltage. So, let us start with the circuit analysis, and let us say this is my battery EMF, E is here. Okay, and this is the point. Before that, the diode will not turn on, because I am considering here a means discontinuous current mode. If you understand this discontinuous and continuous current mode here, you will be able to understand with the full wave and 3-phase circuits also. So, please focus on this concept here only, because this is very simple circuit. All right. So, we know that we are talking about instant to instant. This is 0. Let us say this is alpha dash, where alpha dash is that point when source voltage and EMF battery EMF becomes equal. This is pi, this is 2 pi, this is 2 pi plus alpha dash, this is 3 pi, this is 4 pi, and this is 4 pi plus alpha dash, 5 pi, and so on. All right. So, let us start with instant wise. We have already studied about what are the 7 steps to draw a waveform. So, when first instant comes, first instant is from 0 to alpha dash. When 0 to alpha dash here, you can see in the upper circuit that for 0 to alpha dash, this diode, main diode, is reverse biased, and since initially we are assuming that no load current is flowing, all right. So, this freewheeling diode will also be not working, because this freewheeling diode will also be reverse biased because of this E. All right. So, both diodes are reverse biased. So, the circuit will not be in working condition. So hence the output voltage will be 0, and hence ultimately the output current will also be 0. Output voltage 0 and load current will also be 0, because you can draw its modified circuit, you will get like this, like this. So everything is disconnected. Alright, so there is no load current, no diode current, no source current, no freewheeling diode current, but diode voltage will be there. And what diode voltage will be there, that we have already drawn in the previous lecture with RLE load. That will be a sine wave portion of this shifted by E, means like this. This will be the diode value, voltage across diode. And at this point, when the diode voltage becomes forward biased, alpha dash. So when the diode voltage become alpha forward biased, means new instant we are considering, and that new instant is from alpha dash to pi. Alright, so when we are considering, we have already discussed about why this is not stopping at pi minus alpha dash, because of inductor, high value of inductor, it will continue to means it will continue its operation, because inductor will not discharge at pi minus alpha dash. Alright, it will discharge after some pi at some point beta. So from alpha dash to pi, what is happening, the diode D is becoming forward biased. So when the diode D is forward biased, you can see this freewheeling diode is automatically reverse biased, because when this is forward biased, this is shorted. So this positive side of the supply is here and negative side of the supply is here, hence this freewheeling diode will become reverse biased. So in this case, diode is on, but freewheeling diode is off. So if you draw the modified circuit, it will be like this, which we have studied already in previous lecture. So and freewheeling diode is off, so I am not drawing it. So we can see that this load voltage is in parallel with this source voltage, hence output load voltage will follow the source value. So we can simply draw it like this from this point. Alright, draw it a little more. Like this, okay. And load current, as you know that this is inductor, so inductor does not allow instantaneous sudden change of current. So the current will start rising from 0, and we have already derived it that the current will be exponential plus sinusoidal behavior. So the current will be like this. And at pi, the current will not discharge fully. So current will discharge, let's say at some point beta. At some point beta current is discharging. So obviously when the current is discharging at beta, load current, so I am just drawing load current because we are considering till 0 to pi, but we can draw load current till beta, that is not a problem. But we have to understand till 0 to pi what is happening. Now if you talk about the source current, so obviously from 0 to pi the source is connected to the load, so obviously the source current and load current both are in series, so they both will be same. So whatever the shape of load current is there, the same shape of source current will also be there, but since till 0 to pi, because we are talking about till 0 to pi, okay, source current is there, and in during this alpha dash to pi, diode, freewheeling diode is off, so freewheeling diode current will be 0, and forward diode means this main diode, that is on, hence the diode voltage will also be 0. Alright, so no problem till this point. Now we talked about what is happening from pi to beta. What is happening here? We have to consider that now. So if we want to consider what is happening pi to beta, we know that load current is going beyond pi because of inductor, because inductor does not allow certain means inductor does not means become de-energized, sorry, till the point the inductor does not become de-energized, it will continue to flow its current. But now what is happening, you see, when the cycle is reversing here, when the pi, after pi, when the cycle is reversing, what is happening here, that due to reversal of supply, let me draw it, when the supply is becoming this, minus above and plus here. So, this diode is becoming reverse biased, but this due to, and it initially inductor charging polarities were this, plus here minus here, but when inductor start discharging, the inductor polarities will become like this, like this. So, when the inductor polarities will become like this, and due to high L di by dt, what will happen, this freewheeling diode will become forward biased. You can see, because inductor has high L di by dt, and because of the source also, this freewheeling diode will become forward biased. So, as soon as freewheeling diode becomes forward biased, so inductor current will get a less resistive path from freewheeling diode, rather than keeping the this main diode forcefully on. Inductor will find it easy to go with the freewheeling diode. So, what will happen, as soon as pi instant comes, what is happening, the main diode gets turned off, and the whatever the load current which was flowing from the main diode will be commutated to the freewheeling diode. Please know, means mind this this term commutation. Commutation does not mean turning off of any device. No, commutation does not mean turning off device. Commutation but means that whenever current transfers from one device to another device, causing the previous device to turn off. Because of that, because of commutation, the previous device gets turned off, but means in commutation actually the current transfers from one device to another device. This is the real definition of commutation. Alright. So, what is happening when the current, so at the pi instant, this main diode will be off and this freewheeling diode will be on due to high L di by dt of the inductor. So, what is happening, that this load current will immediately commutate from main diode to the freewheeling diode. So, let us draw this instant here. So, I have this instant from pi to beta. So, from pi to beta, what is happening, the main diode is off, but now the freewheeling diode is on. So, what will be the circuit look like? The modified circuit will look like this. This is main diode, this is on, will be represented by short circuit, and this is our RLE load. So, what is happening here? You can see the load current is still continue to flow in the same direction, but in a discharging mode, means like this. Load current is still flowing like this. Let me make it a little bigger. So, let us draw it here. The circuit modified will be like this. So, what you are observing? The load current is still flowing in the same direction, because inductor polarities have now become this. Okay. So, now node current is still flowing in this, but now the inductor is discharging. So, now if I ask you what will be the output voltage here now? Again, when we talk about output voltage, you can see, since I have told you one concept in my previous lecture, that whenever the load current is flowing in this RLE, in that case the effect of E will not be seen on the output voltage, means E value will not be seen in the output voltage. So, what you see, that both of these terminals are short circuited, alright, by the diode. So, whatever the voltage is here, that voltage will appear across the load voltage, because load voltage, again you see that RLE load is in parallel with the freewheeling diode now, and freewheeling diode has a zero output voltage, zero voltage, because it is a short circuit now. So, what will be the output voltage in this case? It will be 0, but current is flowing, alright. So, if you draw here, what you see, that from pi to beta, load current is flowing still, but the load voltage will be 0. There will be no load voltage because of short circuit. And what will be the source current? Now you see in the circuit, source is disconnected. So source is disconnected, it means what? Source current will be 0. So source current will be like this only till this point, and it will be 0 from pi to beta. And what will be the freewheeling diode current? So whatever load current is flowing, that is flowing through freewheeling diode. So you can see that this portion will contribute to the freewheeling diode current. So you have to just draw the same portion with the freewheeling diode like this. Okay. So you can see that if you add IS and IFD, you will get I naught. And what will be the diode voltage here? You can see now the main diode is off. So what the diode voltage will be here? Now here just see one thing. When the diode voltage you are drawing here, since there is no effect of E here, no effect of E here is not here, alright, is not happening across the diode. So whatever the supply voltage is there, that will be happening across the main diode. There will be no shifting. So what are the benefits of using freewheeling diode? You can see two benefits. First, your load voltage is not becoming negative. So because of that, you still can get higher load voltage average value. Second, it is helping you to keep the load current continuous. Third, you do not require a high value of diode. Alright, here again you see that PIV rating of diode is Vm only. But when the freewheeling diode was not there, without freewheeling diode, the PIV rating of diode was Vm plus E. This was the PIV rating. Alright, so these are the advantages of using freewheeling diode. Alright, another advantage is that means it keeps the input power factor very good. Alright, this point you will understand when you will come to the full wave circuits. Alright, how it keeps the input power factor good. Alright, so now come to the next instant, that is from beta to 2 pi. So when come to the beta to 2 pi, again this main diode will remain off because of supply, and since means the inductor current has also discharged fully here, so this freewheeling diode will also be off. Alright, so hence the circuit will again become like this, which you can see here. Alright, so again the circuit will be like this. So we can draw the output voltage will be 0. Sorry, very wrong lines. The output voltage will be 0. Alright, the output current, load current is also 0. The source current is also 0. Diode, freewheeling diode current is also 0, and diode voltage we have already made. Alright, but here you can see that since current is discontinuous, so what is happening after beta point, again the effect of E will be seen on the main diode. So after this, again this waveform will shift like this, like this after beta. Alright, so here what I said that PIV rating is Vm, this is possible only if this load current, instead of becoming discontinuous, if it becomes continuous current, then this will be true for this circuit. Otherwise the same Vm plus E PIV rating will be required. Alright, so again the next when 2 pi plus alpha, so it will remain 0 till 2 pi plus alpha dash. So we can make it like this till 2 pi plus alpha dash, like this, and again at 2 pi plus alpha dash, again the same circuit will repeat, same steps will repeat. Alright, so we can simply draw like this. This is output voltage, output current, source current, freewheeling diode current, and main diode voltage like this. Okay. Now, if you find the average output voltage here, if you find it, what you will get, the average output voltage, you can see there is no negative portion now. Okay. So, when there is no negative portion here, you can see that average output voltage comes out to be Vm upon pi, Vm upon 2 pi 1 plus cos alpha dash. You can check it, if alpha dash becomes 0, you will get Vm upon pi. So, you can see that this average output voltage Vm upon 2 pi 1 plus cos alpha dash is greater than what we get in RLE circuit. There, if you remember, we get average output voltage something else. Alright. So, these are the advantages of using freewheeling diode. So, now let's come to next circuit, means using this freewheeling diode with continuous current load. This circuit was discontinuous current load. Whatever waveforms here we have made, this was discontinuous current mode. All right. So, now let us study about the freewheeling diode effect for a continuous load current and ripple free, means freewheeling diode with continuous continuous current load, or you can see continuous ripple free current load. So, this continuous ripple free current load is also known as constant current load. So, please remember both of these terms, whether you get constant current load written or you get continuous ripple free current load written, whatever, either of the two, it means what? The load is represented by a current source. Both terms represent this type of load. All right. So, now let us study about this. This is our main diode and this is our freewheeling diode. So, let us again say this is my output voltage, this is my output current, since it is a continuous ripple free current or constant current. So, we can see that the average value of current flowing is I naught here. All right. Let us say this is freewheeling diode reference and this is freewheeling diode voltage reference, this is main diode reference and this voltage and currents, and this is source voltage and source current reference. All right. So, let us start with its waveforms. This is Vm and source voltage is here. So, let us draw load voltage, let us draw load current, source current, then freewheeling diode current and main diode voltage. Okay. So, since you can see this is a continuous constant current load. So, this constant current load may be a pure inductor, it may be a RL type load, or it may be RLE type load. Maybe means in this can be either of them. All right. So, even if this is RLE, hence there is no need to make E here. Why? Again I told you that if you make E here, there is no meaning to draw E here, because when the load current is flowing continuously, you will not see any E in the output. Only for the very first half cycle, in the starting only, the effect of E will be seen across diode, and after that there will be no effect of E will be seen. Okay. So, let us start. So, even if you want to study its effect, that why what I am saying is true or not, let us check. Alright. So, let us say if this is E, okay, if this is E. So, you say that at alpha dash the process will start, okay, I said yes, yes, it is true. At alpha dash the diode will on. So, again at alpha dash the diode will on, so output voltage will be like this, correct, no problem. And we have already considered load current as constant current, so we can draw load current like this, because it is a constant continuous, constant means continuous. All right. So, this is my load current, I can draw it for the whole infinite cycles. Now, let us see at alpha dash, we are starting with the, okay, since we are starting the circuit, so we can erase this much. Oh. Okay. So, this is load current. So, and let us start. So, this will be like this. So, initially at 0 to alpha dash there will be no load current, we can assume. So, and we can say that means the current has risen from here, initially current will rise like that, okay, we can see like this, okay, the dotted portion you can see. Now, what is happening, the source current will also be like this initially, we can make a dotted one like this, okay, no problem. But and the freewheeling diode current will be 0 initially, and the diode voltage will be initially will be like this, okay, no problem. Now, when pi instant comes, so what is happening at pi, this diode, main diode is off and this freewheeling diode is on, the same working which we have studied in this. All right, same working, same instance, okay, the freewheeling diode is on now at pi instant and main diode is off. So, what is happening, but you can see the current will not discharge to 0 now, okay. So, hence when the freewheeling diode will take over the conduction, and the output voltage will be 0, okay, and the source current will become 0 from this point to this point, okay. Now, the freewheeling diode current, now whatever the conduction is here from pi to 2 pi, this conduction will be taken over by the freewheeling diode. So, freewheeling diode will be conducting here, and whatever since conduction is already going on here continuously, hence no E will be seen here at this point. So, what is the reverse voltage across diode now, that will be the source value only. So, that this diode voltage will, the source means whatever the source value is there, so that will be the Vm. So, that is why I have told you, when the current was continuous, then the PIV rating of diode will remain Vm only. Alright. Now, at next cycle, now come to 2 pi only. So, what you see here, will you ever see this E effect at this point A? No. Why? Because the current is continuously flowing. So, when the current is continuously flowing, as soon as the 2 pi instant comes, here the potential is 0 now, because of freewheeling diode the potential is 0 here. So, as soon as the 2 pi instant comes, this diode will become, the main diode will become forward biased, and immediately it will start conducting, because here the potential is, if you say VA, that is 0 here. So that's why you will never see E again for the constant current loads or continuous current loads. So that's why now you will get the output like this, the full cycle, no clipped, which I have got here. And again the source current means load current will be flown by, means load current and source current will be like this, because they are in series, and freewheeling diode is off from 2 pi to 3 pi. So that's why the freewheeling diode is 0 current, and main diode is on, hence the main diode voltage is 0. Again when 3 pi instant comes, again freewheeling diode will take over the conduction and output voltage will be 0. The source current will be 0 at 3 pi to 4 pi, and from 3 pi to 4 pi the freewheeling diode conduction will be like this. And again since main diode is off, so the source voltage will be appearing across the main diode. So you can see, means now again if from 4 pi again the main diode becomes forward biased, but since means at this potential, due to continuous nature of the current, no effect of E is here. So that's why again this diode will be on because of supply only. So that's why again we will get a full cycle like this, and again the source voltage will be like this. Okay, source voltage will be like this, and freewheeling diode current will be like 0, and main diode voltage will be 0. So you can see, now if you consider infinite number of cycles, just this one half cycle is just a trivial one. You can neglect this half cycle, because this half cycle will never appear again. That's why in books, whenever you see with continuous current load and freewheeling diode is there, you will see that they make output voltage like this, and they make source current also like this. They don't show E effect. Alright, and this is there, and this whatever diode voltage I have made here, this will never appear again here. So that's why in books when you see, they show the waveforms like this, complete waveforms like this. So you can see for a continuous load current, you can see the average output voltage is coming like a resistive load, and its value will be Vm upon pi. So still you can see that since the load is still inductive, but still the average output voltage is coming like as that, means coming like that we get in case of resistive load. So this is, and you can see also now in this case the power factor of source current also has improved because of the this freewheeling diode. Okay, and the nature of current also has improved. Okay, we are not getting any loss of voltage. So these are some of the advantages of freewheeling diode. All right. So I hope you have understood what are the advantages of freewheeling diode and how the freewheeling diode changes our circuit and its waveforms. So if you have got any query regarding this or any doubt, any question regarding this, please post in the comment section. And how do you like the lecture? Please also post that in the comment section. Till then, thank you very much.